In this lesson, we'll be looking at how we can solve something called polynomial inequalities using algebra. So just so we all remember, an inequality is a statement that uses the symbols greater than, less than, greater than or equal to, less than or equal to, or not equal. Okay, so we're taking our equalities, equations that use equal signs, we're putting them aside and we're looking at inequalities using these symbols. So let's start with an example. Example A, solve each inequality, show a solution on a number line. So the inequality x minus 8 is greater than or equal to 3. And this statement isn't going to have only one solution. It's going to have a range of solutions. And the nice thing about inequalities is we really solve them in a similar fashion to solving equalities. So if I was solving this algebraically, I would take the negative 8, I would move it to the other side of the equality, and it becomes plus 8. And then I simplify, and I see that x has to be greater than or equal to 11. And how I show this on a number line is by finding where 11 is on the number line. Since x can be equal to 11, I'll put a dot at 11 and color the dot in, and then draw an arrow on the number line showing the range of solutions. So x could be equal to 11, but it also could be any number above 11, up to positive infinity. So again, we didn't get just one answer, we got a range of answers. Let's try B. Negative 4 minus 2x is less than or equal to 12. So same method, we solve this algebraically, which means bringing the negative 4 over to the other side of the inequality. It becomes plus 4. We gather those terms together. So negative 2x is less than or equal to 16. And here's the only difference really between solving equalities and inequalities. When I divide both sides by negative 2, so 16 divided by negative 2, I switch the direction of the inequality. So when I divide both sides by a negative number, I switch the direction of the inequality, and so I end up with x has to be greater than or equal to negative 8. So showing that solution on a number line, since my value can equal negative 8, I draw in the dot, and I show an arrow on the number line indicating which way my range of solutions lies. Anything above negative 8. Just to summarize that special case, when both sides of the inequality are multiplied or divided by a negative number, the inequality is reversed. So it changes direction. Let's look at some more challenging problems. So a polynomial inequality, two terms, this would be quadratic. And we can solve this by using intervals. And we'll make our intervals by looking at the x-intercepts of this polynomial. So on a number line, I know that I have an x-intercept of negative 3. I'll just draw a little dotted line through negative 3 on my number line to show that's where my x-intercept is. And I have another x-intercept at 3 halves. So a dotted line between 1 and 2 on my number line. And then I'm going to test values in each interval. And I'll pick easy values. So looking at my interval that's less than -3, I'm going to test a value of -4. And I don't really care what the value turns out to be. I care about the sign of the full expression. So if I sub -4 into my expression for x, -4 plus 3, that's a negative number. If I sub it in for 2x minus 3, 2 times -4, -8. Take away 3, that's also negative. A negative times a negative ends up being overall positive. And a positive number is greater than 0. So my interval for values less than -3 satisfies this particular inequality. If I plug 0 into this polynomial, 0 plus 3, well, that's a positive number. 2 times 0 minus 3, that's a negative number. A positive times a negative is overall negative. So the interval between -3 and 3 halves does not satisfy my inequality. And finally, I'll pick a value bigger than 3 halves. I'll pick 2. 2 plus 3 is positive. 2 times 2 is 4. Take away 3, still positive. Positive times a positive is overall positive. So that satisfies my inequality. And now I need to just write this up on a number line properly. So drawing in my number line. So I said that values less than -3 satisfy this inequality. And here's the difference between our first two examples. This is strictly less than 0. So since it will never get to this point, I draw an open circle and an arrow pointing to the left to show that any value strictly less than -3 satisfies this inequality. And likewise, at 3 halves, since it's strictly less than, it'll never reach 3 halves, but any value above 3 halves makes this positive. And let's try one more. We're going to solve this cubic function. -2 times the factor x plus 4, which is an x-intercept at x equals -4, times the factor x minus 2, times the factor x plus 1. We want that to be less than or equal to 0. So I'll draw in my number line to show the intervals that I need to solve for. So I'm looking at a x-intercept at -4, an x-intercept at -1, and an x-intercept at 2, which means I have to test values on 4 intervals. So I'll test first a value of x equals -5. If I sub -5 into my factors, I get a negative factor, a negative factor, and a negative factor, and this a value is also negative, so I need to take that into account. So I have 4 negative values all multiplied together. And I get something that's overall positive. And if I'm looking for values that are strictly less than or equal to 0, well, less than means values that are negative. So my first interval fails this test. So then I'll try something in my second interval. Let's try x equals negative 2. So my a value is negative. My next factor would be overall positive. Next factor, overall negative. Again, overall negative. So I get 3 negative values all multiplied together, which would be overall negative. So that works out. Next I'll try picking simple values, x equals 0. My a value is negative, and then I have a positive, negative, and a positive. 2 negatives multiplied together becomes overall positive, which fails this test. And then finally I'll pick x equals 3 as my last test. I get a negative times a positive times a positive times a positive, which is overall negative, which satisfies that condition. So summarizing my answer on a number line, my interval between negative 4 and negative 1 passes this test. It solves the inequality. And since it's less than or equal to 0, I draw a colored dot that's dotted in, colored in. And I just show myself connecting those dots somehow. You can highlight the line. I draw over top so I can see that interval. Between negative 1 and 2 fails the test, so I don't do anything there. But anything above positive 2 passes this inequality. So I show my line continuing. So this means if I wanted to write my solution up a different way, x is between negative 4 and negative 1. And another solution, x is greater than or equal to 2. And that's how we can take these inequalities and solve them algebraically. And that's how we can take these inequalities and solve them algebraically.